So in this session, we will start with our dictionary set, and then we will move to the conditional statements, which is if, elif, else.
Yes.
So first, we will start with the dictionary. So can you tell me what is dictionary?
Dictionary, like what's it called, like a special or, or like a reserved words or reserved commands or special,
No,
something I
the
don't.
dictionary is data type. It's okay. So dictionary is another data type in Python, and it is like a combination of key value pairs. And dictionary are mutable in nature, which means we can make changes in the dictionary. So how we can create a dictionary? Simply we have to name the variable, let's say dictionary underscore one, and then we enclosed dictionary inside curly braces. Then we have key value pairs. For example, let's say we have name and then we have value John. Then we have, let's say, age, and then we have some age. So this is dictionary where name is a key, John is a value, and it is one key value pair, which is name and John. Then second key value pair is age and 18. Age is a key and 18 is a value. So that is dictionary. Now dictionary has the combination of key value pairs. So this is key and this is value. So they are like key value pairs. And they are
Mhm.
mutable in nature, which means we can make changes in the dictionary. We can add items, we can remove items, we can change items. That is why it is mutable in nature. Secondly, dictionary are order in nature, like they follow a particular order. For example, if I print dictionary underscore one, so here we have a order, which is name is coming first and then age. As per my dictionary, it is not like age is coming first and then name. So it is in order, the order which I have created. So dictionary is in order in nature. Secondly, the dictionary doesn't allow duplicates value, like duplicates key. Means we cannot have another age here, like this one. We have same values, which is let's say 18 here, but different keys. Age is a key, age is another key. So we cannot have same key, but we have different values. For example, we have score here. Score can be 18 here, which is 18. 18 is a value. But we can have same values, but not the same keys. So which
Mhm.
means in the dictionary, duplicates are not allowed. So these are some properties of dictionary. Now we will perform some operations like some methods and some functions which we can perform with the help of dictionaries. So this is first way of creating a dictionary. Now we can also create the nested dictionary. Okay, which is dictionary inside dictionary. For example, we have this dictionary underscore second. Let's say we have a dictionary here, which is name of, let's say we have fruits here. Okay. Now inside fruits, we can have another dictionary. So here we can put another curly braces and then we can put key value pair here as well. Let's say A equal, let's say 1, B, a very simple dictionary. Let's say we have comma C, which is 3. So this is dictionary inside dictionary. So we have this key here, a single key of this entire dictionary, and we have this value here. Inside this value, we have another dictionary. So this is known as nested dictionary, which is dictionary inside dictionary. We can have list inside dictionary, we can have tuple inside dictionary, we can have set inside dictionary. So we can have any data type inside dictionaries. Okay, so we have this dictionary inside a dictionary. So this is known as nested dictionary. Okay, in the nested dictionary, we have this A is a key, 1 is a value, B is a key, 2 is a value, C is a key, and 3 is a value of one dictionary, which is a value here. And then this value, the key is fruits. Or we can name it anything. Let's say alpha. Okay, so alpha is a key and we have this value here. We can have another dictionary. Let's say we have another value. Let's say we can have numbers. Okay. And we can have another dictionary. Let's say we have numbers. In this number, we can put D equal, let's say 4, comma E. 5. So if I press enter here, so you can see this is first key value and this is second key value pair. Inside this key value pair, we have two dictionaries. First key is alpha, second and first dictionary inside dictionary is this dictionary, which is a value of alpha key here. Okay, so in place of value, we have another dictionary as a value here. Then we have second key here, which is numbers. Inside this numbers, we have this value here, which is a whole dictionary. So this is known as nested dictionary. Now, how we can access items inside dictionary? So let's say I wanted to access any key or any value of any particular key. So here, let me comment this one. We can print here. Let's say from this dictionary, I wanted to fetch name here, which is John. So I can put name of my dictionary _1. Here I can put a square bracket and then name here. So I am calling name as a key. This will print the value of name, which is John here. Because John is a value of key name here. So if I run this one, you will notice John. Okay, so John is a value of name key. Then let's say I wanted to fetch. This is one way of fetching the values. Another way of fetching our values is like we can use print and then we can use dictionary _1. And here we can use dot get method. Get. And here we can mention the name of the key. Let's say age. So in this second statement, I will have 18 here as a age here. Okay. So if I run this one, you will notice 18. So this is one way of fetching values and this is second way of fetching values. We are doing the same only. We are fetching the value of a specific key. Name is a key and here we are fetching value of name, which is John. And here we have this John. Second, we are fetching age, which is like the value of age, which is 18. So this is another way of fetching the values. Okay, so we have two ways of fetching the values of any specific key. Then we can also mention, we can also print all the keys of a dictionary. You can use print dictionary _1 dot. We can put here dictionary _1 dot keys. So this will fetch all the keys from the dictionary. If I run this one, you will notice name, age, score. Name, age, score. These are the keys. Name, age, and score. These are the keys. John, 18, 18 are values. So we can also fetch values only. So if I run this one, we can copy the same here. In place of keys, we can put values. So now in place of keys, we will have values, which is John 1880. You can see John 1880. So this is how we can fetch keys and values. We can fetch both, like we can use here dictionary 1 dot keys dot items. With the items, we can fetch everything, which is name, John, age, 18, score, 18, like this one. Okay, you can see name, John, age, 18, score, 18. So with the help of items, we are fetching everything. With the help of values, we are fetching values. With the help of keys, we are fetching keys. With the help of key, we are fetching values, which is name, and we are fetching value John. Okay, like this one. So these are important methods. Next method is we can check if any key is present in the dictionary or not. Okay, for example, this is my dictionary. So we can check with the help of in operator. So what we can do, we can check here print. We can put here, let's say, name in dictionary _1. So this will return true or false. If the key is present in the dictionary, this will return true here. Okay, true. Because name is inside my dictionary _1. If I mention, let's say, son name or let's say last name, so this will return false because I don't have any last name as a key here. I just have name as a key, not last name. So we can check if any specific key present in our dictionary or not. Same as we can check for the values. Okay. So this is checking if any key present in the dictionary or not. Is it clear this much?
Yes, teacher. So that checking key present is a true or false output, has teacher.
Yes. If the key is present, then we will have true. If the key is not present, we will have false. That's it. Okay, like we have only to output true or false.
Yes.
Then we have change values. As I said, that dictionaries are mutable in nature, which means we can change values. So let's say I wanted to change value of score here, which is, let's say I wanted to change score value. So how do I change? I can mention my dictionary name, which is dictionary underscore one, and then the key I wanted to change the value of. Let's say I wanted to change 18 to, let's say, 50. So this is my new score. Now, if I print dictionary underscore one, you will notice 50 in place of 18. Okay, you can see 50 in place of 18. So here we are
Mm,
changing elements. We are changing values of score here. You can change any value, like you can change value of name, you can change value of age, or you can change value of score. So you have to mention your dictionary name, your variable name, and name of your key of which you wanted to change the value, and then your new value here. Okay. So this is changing the key. Now we can also update the dictionary. Or we can update, let's say I wanted to add, let's say I wanted to change age here. Okay, so we can also update like this one. Let's say we have this one, dictionary underscore one, okay, dot update. Now what I wanted to update, I have to mention that. So let's say I wanted to update name here. And from name, I want to put my name. Let's say my name. So now here I'm updating name here. So name is a key here, and I am updating John with my name here. So if I print dictionary, you will see name has been changed. Previously it was John. Now I have changed to my name. Okay. So we can also update like this one. So we have one way of updating, like we can change values, or we can update the like the values by putting update here. Update name of your key and value you wanted to change. Then how we can add elements? Adding elements in the dictionary. Adding elements means we have to add key and value both. So we can simply mention a like a new name here. Let's say dictionary underscore one, and here I can put value I wanted to add. Let's say language, and here I am adding Python, and now I can print dictionary underscore one. So now language, we don't have any language key here. We have name, we have age, we have score here. We don't have any language key. So this language key will be added and Python value will be added here. So if I run this one, you will notice we have this name, age, score, and language Python. So if you want to add values or add any item, you just mention the name of your key and then its value. If you want to replace item, then you have to mention the previous key, like pre-existing key with its value. Okay. So this is how you can add and this is how you can update the dictionary. Is it clear? This much?
yes, clear. Yes, clear,
Okay.
teacher.
So let me comment. So this is how we can update, add elements. Now what about removing? So we can also remove elements. So let's copy this dictionary here. Now let's say I wanted to remove a score from this dictionary. So we have again some methods of removing the items. First method is we can use my dictionary name dot pop. You can use pop here and the key I wanted to remove. So let's say I wanted to remove score and its value. So I will put here score, like the key and value I wanted to remove. So I wanted to remove score, so the score will be removed. And if I run this one, dictionary underscore one, so you will notice name and age. Name and age. Score has been removed from the dictionary with the help of pop here. Pop score. In place of pop, we can also use pop item. Okay, so this is pop here. We can mention pop Pop is a method. Okay, same as we can use pop item. So let's say if I use here, again I can use dictionary and store one pop item. Okay. So this pop item will remove the last element from my dictionary. So if I just remove this one and if I print again, dictionary underscore one. Okay, so pop item will always remove the last element from my dictionary, which is score. Score is my last element, so pop item will remove the last element. You can see score has been removed. If I run this again, you will notice age will be removed. So if I run this again, you can see we have to again apply this one dictionary underscore one dot pop item. And then we can print dictionary underscore one. So now I'm removing first item, which is the last item, score, and I'm removing the age, which is the second last item. So if I run this one, you will notice just name only. Okay, just name, John here. So pop item, the difference in the pop and pop item is pop item will always remove the last element. Okay, always remove the last element. And pop, this simple pop will remove the element of your choice.
Mhm.
Okay, of your choice. So here in the pop, we are mentioning what kind of which element we wanted to remove. But in the pop item will always remove the last element.
Mhm.
Okay, so this is how we can remove. We can also delete items. Like for example, we can also use to delete. So we can just mention the name of Dell and then name of my dictionary. Now what I wanted to remove or what I wanted to delete. So that I can mention. Let's say I wanted to delete name here from the dictionary. So if I mention del, which is delete, dictionary underscore one, name of my dictionary, and what kind of key or which key I wanted to remove, which is I wanted to remove name here. If I print again my dictionary underscore one, you will notice name will be removed from the dictionary. Okay, you can see now we have just age and score because the name has been removed. If you are not mentioning anything, so this del dictionary one will remove the entire dictionary without anything. Like it will remove everything in your dictionary. So if I run this one, you will notice a error here. Okay, you can see error. Because we are
Mhm.
removing the entire dictionary. We are deleting the entire dictionary from the memory. After
Mhm.
deleting the dictionary, I am asking it to print it, which I have already deleted. So that is why it is giving the error here. Because I have removed or deleted the dictionary. So this is second way of deleting the dictionary. We can also use clear. Okay, in apart from the delete, we can use clear here. So we can use dictionary underscore one dot clear. Clear will clear your dictionary, like empty your dictionary. If I run this one, you will not notice nothing here. So this means your dictionary has been like the dictionary is there, but the elements, all the elements within the dictionary has been removed. Okay, so we have these four elements, or we can see four functions of removing the items. First, we can use pop, then we can use pop item, then we can use del, and then we can use clear. So it's your choice. It depends on the requirement. Whatever you wanted to apply, you can. Like it depends on a requirement. Okay, so clear will basically clear the dictionary, which is empty. Then we can copy a dictionary. Like how we can copy a dictionary into another dictionary. For example, we have this dictionary which is dictionary underscore one. Let's say I wanted to copy this dictionary. So I can put dictionary underscore two. And here I will use the copy method. Okay, so I will use dictionary underscore one dot copy. So now the dictionary, I am copying the dictionary number one into dictionary number two. So if I check dictionary number two, it will contain the same element as dictionary underscore one. Okay, you can see. Now, what is the benefit of copying the dictionary? Like, what is the benefit? Let's say we have two ways of like copy the dictionary. We can also do this one, equal dictionary underscore one. So we have two methods. First method is we are just assigning the dictionary one into dictionary number two. Now dictionary one and dictionary number two contains the same element. But second method is we are copy the dictionary two, and dictionary one into dictionary number two with the help of copy method. So what is the difference in first method and second method? The first method will not reliable because let's say if I'm making changes in my dictionary number two, so the changes which I'm making in my second dictionary will be made in the first dictionary as well. Which means if I'm making the changes in my dictionary underscore second, the changes will be also applied in the dictionary underscore one. So that is why we avoid using this mechanism. We use copy method. With the help of copy, we are copy the dictionary one into dictionary number two. Now, if I am making changes in the dictionary number two, the changes will not affect the first dictionary. That is like how copy method works. So that is why we prefer to copy rather than just assigning dictionary one into dictionary number two. Okay. Is it clear? Like the
Yes, no.
difference?
Yes, teacher.
So this is one way of copy. Second, we can also use like this one, clear dictionary number score two, and we can use let's say like we can use a variable like dictionary, and here we can use dictionary underscore one. So we can use a dictionary constructor here, and we are assigning dictionary underscore one to dictionary number underscore two. If I print dictionary two here, you will notice the same elements as dictionary underscore one. But again, this method is not reliable because whatever the changes I will make in the dictionary number score 2 will also affect my first dictionary. So I will avoid this mechanism. Okay, so we can write here note, please avoid this method. Always use copy method to copy the dictionary. Okay, so this is a no. So we always use copy here, this one method to copy the dictionary from one dictionary to another. Okay, is it clear this much? Any questions?
No, teacher.
Okay. Then we have this concept of nested dictionary. Like we can create another nested dictionary. Let's say we have a dictionary name child one. Okay, child one. Here we can create a dictionary. Let's say the dictionary name is name here, and we can put any name. Let's say we can put Emily, comma, we can put a year here. Let's say year is 2004. So this is our first dictionary. Then I can create child underscore two, child two, and here I can create another value here. So let me copy this one, and here I'm pasting. Now here I can just change values here. Let's say we can put John here. Now we have this child three equal, and we can again change value here. Let's say we can put any value. So we have child number one, we have child number second, and we have child number three. So these are all individual dictionary. This is dictionary one, a simple dictionary, dictionary second, and dictionary three. In each and every dictionary, we have two key value pair. First key value pair is name. Second key value pair is year. So what we can do, we can combine this entire dictionary into one dictionary. Let's say family equal. And here we can assign child one. We can assign child two. And then we can assign child three. So now child one is a key here. And here we are assigning child one, which is this dictionary as a value here. Okay, which means this dictionary will be inside this value here. Same as we have this child two key inside this child two. we have this value here, which is child 2 value. You can see here. Same as in child 3, we have this value, which is child 3 value. So if I print a family here, you will notice everything. Okay, you can see child 1, and here we have this name, Emil, year 2004. Child 2 here, child 3 here. So this is another way of creating a nested dictionary. So what we can do, we can create nested dictionary like this one, which is this one also, or we can create nested dictionary like this one. We can create individual dictionary and then we can combine individual dictionary into one dictionary with the help of key value pair. So this is another way of creating a dictionary. Okay. So that's all with the dictionary. Like we have this much methods and functions in the dictionary. We have other methods, but those are not as much important. Okay. Now we can move to set and frozen set. Okay, after string, list, tuple, dictionary, then we have at last set. Set, what is set? Set is a collection of unordered, unchangeable, and unindexed data type. Okay, so basically we how we can create set. We have the set underscore one. We create set with the help of curly braces, and then we can put values here. Like it can take any kind of value. Okay, so this is set. Now in the set, duplicates are not allowed. Like we cannot put one again, like this one, or two again. So this will not permit it. We cannot use duplicate values. Secondly, set are unordered in nature. So if I run this set, you will notice an unordered nature. So if I print set underscore one, and if I run this one, okay, here let's say if I put something else, let's say 5, 6, and 9, like this one, you will notice no order here. Okay, now you can see my order is 1, 2, 3, A, B, 5, 6, 9. But here you can see the order has been changed. It is 1, 2, 3, 5, 6, A, 9, B. If I run this again, you will see another change in order. If I run this again, you can see another change in order, which is 1, 2, 3, 5, 6, 9, A, B. So my order is different here. Here this order is different. And every time you run this set, you will find the different order here. So that is why we can say set is unordered in nature, unchangeable, which means set is immutable in nature. So we can say set is both immutable and mutable both. Okay, now why set is mutable and immutable both? Set is immutable because we cannot change the elements of the set. For example, if I wanted to change, let's say 1 to any other value, let's say 10, I cannot change it because set is immutable in nature. But let's see if I want to add something. Let's say I wanted to add any other value here in this set, I can add value. Or if I wanted to remove any value, let's say I wanted to remove 9, so I can remove, which means set is mutable in nature also. So we have the set which is both mutable and immutable. Immutable in the sense that we cannot change elements. Mutable in the sense we can add items or we can remove items, but we cannot change items. That is like how set is mutable and immutable both. Okay. Now what kind of features we can perform, like what kind of operations we can perform with the set? So this is first method of creating a set. The second method of creating a set is using set constructor here. And here we can put like any value, let's say 1, 2, 3, 4, or any value. So this is another way of creating a set. First way of creating a set is using curly braces. Second way of creating a set is using set constructor. Okay, so we can use either of the ways, but mostly we will use this way of creating a set using curly braces. Okay, give me a second. Okay. So this is first way of creating a set and this is second way of creating a set. Now what kind of operations we can perform with the set? So let's see. So first we can print this set underscore one. Okay, so here we have no indexing in the set. Now what is indexing here? Indexing are like we cannot print values on the basis of index. For example, in the list and in the tuple, we have index like 0, 1, 2. But in the set, we don't have any index, which is unindexed. Because the set is unordered in nature, which means the order of the set is like keep on changing. So that is why there's no fixed value of the elements. So that is why there's no index value in the set. So we cannot perform indexing here and we cannot perform slicing here. Okay, so what we can perform is we can check for any element. Let's say we can check if A in set underscore one or not. Okay, A is an element in the set. So if A is there, it will return true, otherwise false. Okay, so A is present in the set. So we can check first if any element present in the set or not. Okay, then second is we can use change items. Okay, now we cannot change items. So this is we cannot change items. For example, if I wanted to change A to any other value, I cannot because set is immutable in nature. But what I can do is I can add items. Okay, because set is mutable also. So I can add items. For example, let's say I wanted to add set underscore one dot add C. So I'm adding another value C. And if I print again, which is set underscore one, and if I remove this check here, yeah. So we have this set and I'm adding C in this set. So you will see we can add values. So we have this C here in the set, C here, which means we can add values, but we cannot change values. That is how it works.
Mm-hmm.
Same as we can update set. For example, let's say we have set underscore one. If I copy this set, we have this update set here. So this is set underscore one. Let's say I have another set underscore two, which contains some other elements. Let's say we can have apple, we can have cherry. Now what I can do, I can combine set. I can combine set underscore two into set underscore one. That I can do, which means I can combine set. So here I can write set underscore one dot update set underscore two, which means I am adding set underscore two inside set underscore one. So if I print set underscore one, so you will notice in this set underscore one, we will also have apple and cherry. So if I run this one, you will notice apple and cherry in the set. So we can also update with the help of update element or we can add items. So you can also add item individually or you can combine set together. So this is combining two sets together. So that is known as update method. Okay. We can also add any list inside set. For example, in place of set underscore two, we can have set, let's say we have list underscore one. Now, even I can add list inside set. So for example, let's say if I have list of this apple and cherry. Okay, let me remove this one. So what I can do, I can also combine list and set together. That is like a important feature in the set. If I mention list underscore one. So now I am adding the list underscore one inside set underscore one. So apple and cherry of the list will be added to set underscore one. If I run this one, you can see apple and cherry inside set underscore one, which means we can also combine set and set together. We can also combine tuple or list inside set. That is another feature of set. Okay. After adding or updating, we can also remove elements. Let's say I wanted to remove any element. So for removing, we can use set underscore one dot remove. Now the element you wanted to remove. I wanted to remove, let's say, A here from the set. So the A will be removed from the set. So I will use set underscore 1 like this one. So if I run this one, you will notice A is removed. Okay, previously we have this A because of this print statement. We are here. Then after removing the A element, we don't have any A here in this set, in the new set. So this is first way of removing. Second way of removing, we can use discard. Okay, we can use here discard, which is, let's say, again, I wanted to discard element A. Okay, element A I wanted to discard. So now element A will be removed. So what is the difference in the discard and remove? See, when we use remove, and let's say you are removing an element which is not exist in the set. So in that case, the remove will throw the error. But if you're using discard, and if the element is not present in the set, discard will not throw the error. So that is like the main difference. If you're using remove, so we have to make sure in the beginning that the element should be present in the set. Otherwise, the remove will throw the error and your code will stop executing. But if you're using discard, so discard will remove the element. And if the element is even not present in the set, it will not throw the error. Okay, if I run this again, you will notice no error here because we have removed the like element A. So this will not throw the error. If I see run this again here after this set, now in the previous here I have discarded A here, but after discarding I am again discarding A, which is again removing. So this will not throw the error. Okay, you can see no error here. But if I use remove here in place of discard, remove will throw the error because here I have removed the A. I'm again removing A, which is not present in the set. So if I run this one, you will notice a error here. Key error A here, which is A is not present in the, sorry, yeah, A is not present in the set and you are removing it. So this will throw the error. But if you are using discard, discard will not throw the error if the element is not present in the set. That is like the main difference. Is it clear this much?
Yeah. So again, here, so discard and remove. I'm not clear about this discard and remove. Remove I understand, but discard is like you're ignoring, right?
No, see. For example, in the remove, we are removing the element A. For example, I have this set here. In this set, I have A element, right? We have this A element. Now I am removing this A element with the help of remove. That is
Yes,
remove here. Okay,
correct.
now the function of the remove and discard are same only. The difference is, let's say with the help of remove, also I am removing A. With the help of discard, also I am removing A. But what
Oh,
if any element is not present in the set? For example, let's say I'm removing here C. C is not present in my set. So let's say, let me show you an example with the help of remove first. If I am removing any element which is not present in the set, or we can say already removed. So the remove element, remove function will throw the error. You can see there's an error here, which is key error. C here.
mhm,
Just C is not present in the set. So this will throw the error if any element is not present in the set. But
mhm.
if I remove, but if I use discard here, if I discard C here, again C is not present, but discard will not throw the error. It will handle the error. You can see there's no error here.
Oh
Okay,
yeah,
which means discard is just handling the error properly rather
mm-hmm.
than giving the error. Okay,
Correct.
that is like the difference.
I, I understand, teacher. Thank you.
After discard, we can also use pop for removing the elements. So here again, we can use set underscore pop, sorry, underscore one dot pop. Pop will remove the last element of the set. So if I print set underscore one, basically not the last element, any random element, because there's no last element in the set. Set is like unordered in nature. So in the first go, you can have any last element like B, or in the second one, you can have any other element as a last element because set is like unordered in nature. So pop will remove any element randomly. For example, if I run this one, you will notice with this. 1 has been removed from the set. Okay, which is, it will remove elements randomly. So we have pop. We mainly use discard for the set because it will handle the error. Pop method will remove your any element random. After pop, we can also use clear. Clear for clearing a set. Okay, we have this set underscore 1 clear. So clear will empty your set. So if I run this one, you can see we have no element in the set. Set is empty here. So this is clearing the element. After clearing, we can also have delete. We can also delete the set, which is del set underscore 1. So this will completely delete your set. So we can also use delete. You can see most of the items are like most of these like functions are same only. In the
Mhm.
tuple, in the dictionary, in the set, in the string, we have same element like delete, clear, pop, remove. They are like all same. We can also have length here to know the length of the set. So we can print the length of the set underscore 1. What is length? Like how many elements are there in the set. So we are around 0 element because we have cleared the set here. So let me remove this one first. Now we can run this again. Let's see. Let's count how many elements. 3 and 5 and 8 elements. Okay. So in this set, we have 8 elements. If I run this one, you will notice 8 elements. So we can also use length here to check the length of the elements. Then we can use join sets. We can join, we can join two sets together. For example, let's say we have this set underscore 1. We have this join here. So let's see. We have this set underscore 1. And we can use set underscore 2. Okay, so let me make this set easy. So just removing some elements. So in the first set, I have this one ABC. In the second set, I have 1, 2, 3. So I can join sets together with the help of union. So union is a method in which we can in which we can join set together. Okay, so we have this print set 1 dot union set underscore 2. So you can see in the set 1, we are joining set 1 and set 2 together. So in the set 1, we are adding 1, 2, 3 as well. So you can see in the set 1, we have this 1, A, 2, 3, CB. Okay, which means I'm just adding set underscore 2 inside set underscore 1. So in the set 1, we will also have ABC and 1, 2, 3. Everything. Let me remove this. Okay, so in this set, we have this 1, 2, 3 and ABC. With the help of union, we can join the set. After union, we can also use update. Okay, we can use update for joining the set. Like we can use print set underscore 1 dot update set underscore 2. Okay, so this is second method of joining. This is
Yeah.
first method of joining. We can use union. And this is second method of joining. We can use update here for joining the set. So you can use any of this method. Both are reliable. After join, we have this intersection. Intersection is like it will combine the common elements into another set. So let's say we have this intersection. Let's see with this set underscore 1 and with set underscore 2. If I run this one, print set underscore 1 dot in intersection set underscore 2, you will see nothing here. Because in the set underscore 1 and set underscore, we don't have any common here. ABC are different elements, 1, 2, 3 are different elements. Let's say in the set underscore 1, I have 1 here. So now 1 is common in the set 1 and 1 is common in set 2. So we will have 1 here as a result. 1. Only 1 here. Because 1 is common in the set 1 and set 2 both. So the intersection will print the common elements, which is common elements present in both the set. Okay, let's say I have A here in the set underscore, let's say here, 2 as well. So now within set 1 and set 2, I have two elements in common, 1, 2, 1, 2 in both set, 1, 2 here and 1, 2 here. So if I run this one, you will notice 1, 2. So the intersection will print the common elements. Okay, is it clear this much?
Yes, teacher, clear for me. Yes.
After this intersection, we have one more method, which is
Mhm.
symmetric underscore difference underscore update. Okay, so we have the symmetric underscore difference, and then we have this another feature, which is, let me copy the same here, symmetric difference. So let's run one by one. So we have this one, we have this set 1 and set 2. And here we are using symmetric difference update. So this will return none here because, so this symmetric difference will return everything, but not the duplicate values. So let's see here. We are just returning set 1 and set 2 together. I think something is wrong here in this set. Let's see with this ABC, and we can also put, let's say we can put here B, C, and D. So in this case, we will have A and D. Okay. So what we can do, we have to create a new variable here. We can use set underscore 3. Now set underscore 3 is another set here. Inside set underscore 3, I'm putting this set. So I can print now set underscore 3. So you can see none. So there's some error here. Let's replace set 2 with set 1. So basically we have the, yeah, now it is working. So in this, it will avoid the common elements. For example, in this set, we have this A, B, C. In the first set, we have A, B, C. In the second set, we have B, C, and D. So in both set, we have A is common. Okay, because A is present only in one set. B is not common because B is here also and B is here also. C is not common, C is here and C is here as well. But D is again not common. D is unique here. So A and D are unique here because they are not present in another set. A is a unique element in set 1, which is not present in set 2. Whereas D is a unique element which is not present in set 1. So the difference will print the elements which are common, sorry, which are unique in each other. For example, A is not present in set 2 and D is not present in set 1. So that is why we have A and D here. But B is also present in set 1 and set 2. Same as C is also present in set 1 and set 2. That is why it will avoid duplicates value. It will print the unique values.
Mhm.
Then with this symmetric difference. So let's run
Mhm.
this one. We can again use the same mechanism, which is set 1, symmetric difference, and print set 1. So this is opposite. Okay, this is opposite. So what it will do, it will print the common values. Okay, which is ABC. Okay, now this ABC is common. A is present in the set, B is common, and C is common. If I run this again, we will see ABC again. If I change here to set 2 and set 1 here, and if I put here set 2 here, so you can see BCD from this set underscore 2. Okay, so this will print the elements which are not present in both the set. So I think we have to put it in another variable. Then only it will work. Set underscore with. See, there's no difference in the symmetry difference and symmetric difference update. Like the difference is in the symmetric update, it will not allow the duplicates value. Okay, while in the symmetry difference, it can allow the duplicate values. So that is like the main difference. So overall, we have four functions. We have this union. Union will keep everything. It will like join the set one and set together. Intersection will always keep the common elements present in both set. Symmetric difference update and symmetric difference will keep only the unique elements if the elements are present in a single set. Okay, so that is this feature. After this one, I think we are done with the set. Like we have two more features, which is superset and is subset, and then which is superset. Okay, so let's see, we have this set again. So we can copy here and we can paste it. And we can create another variable, let's say set underscore 3. In this, we can put set underscore 1 dot is subset. So we are checking if the set underscore 1 is the subset of set underscore 2 or not. And then we can print set 3. You can see false because set underscore 2 is not the subset of set underscore 1, which means in the set 1, we have different elements. In the set 2, we have different elements. For example, let's say in the set, we have elements A, B, C. In the set, we have A, B, and C, just B and C. Now, this set underscore 2 is the subset of set underscore 1. You can see answer is false. That means so. We have to replace set 2 with set 1 here. Now we can say set 2, which is B and C, is the subset of set 1. True here. Because you can see here, in the set 1, we have ABC. In the set 2, we have BC. Now BC present in the BC in the set underscore 1 also. So we can say set underscore 2 is the subset of set underscore 1 because set underscore 2 present contains the same element which is also present in the set underscore 1. So this is subset. It is opposite opposite of superset. If I run superset here, which is like the opposite here, like this one, this is subset, we are checking, and then here we can put superset. So this will return false because it is opposite of subset, false. But if I change values here, set 1 to set 2 here, this will return true here. You can see true here because set 1 is the superset of set 2. Okay, you can think of a opposite of subset. In the subset, we are checking if the set 2 is the part of set 1 or not. So it is the part because B and C is also present in set underscore 1. Same as here, we are checking for the superset. We are checking if set underscore 1, which is ABC, is the superset, like superior to set underscore 2 or not. So it is because BSC is present in set 1 and BSC is also present in set 2. So that is why we can say superset is set 1 and subset is set 2. I think like this is like kind of confusing, but if you play around, you will get the idea of like what is superset and what is subset.
Hmm.
Is it clear this much?
Yes, teacher. So usually we can use that. Okay, maybe later because I don't know. Superset is almost similar, really closer similar to is subset, huh, teacher? Because we have a
Opposite.
common. There's a two common character or character, right? For set one and set two,
See,
right? The B and C.
yeah, let me clear it one more time. See, we have the set 2 and we have set 1. In the set 2, if I let me draw it. Just if we see here that set 2 we have and we have set 1. So we can see in the set 2 we have B and C element. In the set 1 we have A, B, C. So now here we can say the elements which are present in set 2 is also present in set 1, right? So here we can say that set 2 is the subset, or we can say part of set underscore 1. Because you can notice here, if we cut this part, this becomes set underscore 2, because B and C is also present in set 2. So we can see set 2, which is this one, is subpart, which is subset of set 1. Okay, because we can see B and C is also present in set 1 and B and C is also present in set 2. But we cannot
Okay.
see the opposite. If I say opposite here, which is, if I say that ABC is the part of BC, that is not possible, because in the set 1 we have A also, but in the set 2 we don't have A. So we cannot say that set 1 is the subset of set 2. But we can
Okay.
say the opposite, that set 2 is the part of set 1, because we have the common elements B and C here.
Mhm.
That is
So
subset of type of
I
part.
understand. I understand the subset, teacher. So how about the superset again?
Yeah. Superset is like, it is opposite of subset. Now
Opposite.
we are saying that set 1, which is this one, ABC, is the superset, which is superior to set 2. So it is superior because you can notice B and C is present in set underscore 1 also. So in the set 2, we have two elements only, B and C. And these two elements are present in set underscore 1 also. So we can say set 1 is the superior of set 2, because set 1 also contains the element of set 2 here. But we cannot say like this one, that set 2 is the superset of set 1, because in the set 1 we have A also, but in the
Mhm.
set 2 we don't have A here, we have only B and C. So we cannot say that set 2 is the superset of set 1, but we can say that set 1, which is set 1, is superior of set 2, because you can even count the number of elements. In the set we have 3 elements, in the set 2 we have 2 elements. So if we wanted to make set 2 the subset, like sorry, the superset, we have to add A also, like A here. Now they are equal. Okay, they are equal here. No one is subset, no one is superset. But if I remove A from here, now set 2 is become lower than set 1. Or we can say
How
not
about
lower, like a part of set 1. Because you can see
excuse me,
B and
teacher.
C is the part of,
Yes,
yeah.
yes, teacher. Excuse me. What if you in the set two you add another character letter E?
Okay, let's check it. If I
Yeah.
add here, E here. So this will return false here. Okay, so if
Oh,
I run this one, you will see,
yeah.
first we can check for the
Mhm.
subset. So this will return false. You can see, because we have E here now. E is not in the set 1. So that is why they are not, like set 2 is not the subset of set 1, because we have another element E here. Now E is not present in set 1. So how can we it a part of a set 1? Okay. So this will return false here,
Boss.
which
How
is
about the is supet? His
superset.
sup
So
yeah, superset.
yeah. So this will also return false. Okay,
Okay.
why? Because set 1, again, we have different elements in both set. So if I run, it will also return false. Because set 1 is not superior now. Because in the set 1, we have ABC. In the set 2, we have BCE. So we have,
Oh,
again, one element which is not similar to set 1 and 2. So we are mainly checking for the commonality here, like common elements here. Which one is common? So if I remove E from here, now we can say set 1 is superset, which is superior to set 2, because whatever the elements present in the set 2 is also present in the set 1. But if I add another element E here, now this element is not present in the set 1. So that is why it is not superior. No one is superior here. They are like
oh,
equal here.
yes, I got
Okay.
it. Understand now, teacher. Thank you.
So at last, we can check for the frozen set. So in the frozen set, we can, now what is frozen set? So we have this set which is both mutable and immutable. So that is why we have this frozen set. Frozen set is purely immutable, which is, it is another form of set only, but in the mutable form. So immutable form, which is this set, this frozen set is fully immutable. Like we cannot add items, we cannot remove items, and we cannot change the elements of the item. So if I run set, let's say frozen equal, we can use here frozen set, and then we can create set underscore one, a frozen set, which is this one. Or we can, you can make any set a frozen set. So if I run this one, print frozen here, so you will notice the set underscore one converted to frozen set. So there's no difference in the frozen set and set. The only difference is set is both mutable and immutable, but frozen set is simply immutable in nature without mutable, which is like frozen set is completely immutable. Like we cannot change elements, we cannot add items, we cannot remove items. While in the set, we can add items and we can remove items, but we cannot change elements. That is why set is both mutable and immutable. And for making set fully immutable, we have frozen set. Is it clear this much?
Frozen set, wait, teacher. So frozen set to set one. When you say immutable, teacher, cannot change, right?
Yeah, cannot change. Exactly.
Okay. Okay, got it.
Okay. Now we can move to conditionals. Tomorrow we will solve the questions for the set, frozen set, dictionary, tuple, and string. Okay, and for the conditionals. Today we will complete the conditionals part so
Okay,
that we
teacher.
can like we will solve all those questions all together. So tomorrow for 2 hours we will solve all the questions. Okay. Today
Mm-hmm.
we will cover the conditionals and loops.
Okay, teacher.
Now, we have conditionals statement. Conditionals, before conditionals, we have this one, which is known as control flow. In the control flow, we have two types of statement. First, we have conditionals. Okay. First, we have conditionals. And second, we have iterations, which is loops. In the conditionals, we have three types of conditions, which is if, elif, else. In the loops, there are two types of loops, for loop and while loop. So we will cover this. Now, what is conditionals? Let's say you are making any decision in your program. In that case, we use conditionals. So conditionals are also known as decision making statement. Decision making statement. Now, what is this decision making statement? Let's say you are making any decision that a person can vote or not. If he or she can vote for or vote for any particular party or not. Like if a person is eligible for vote or not. You are making this statement. Now you are checking if any person, let's say my age is 15, let's say. So now you are checking if I am eligible for vote or not. Let's say my age is 46. So now you are checking again if I am eligible for vote or not. So whenever you are making any decision in your program, you use conditionals like if, elif, else. Now how to
Okay.
use it? The syntax is very simple. They are like very simple. In the conditionals, we used if. Okay, mainly we use if. Okay, if and your condition here. Any condition you are checking. So this is a syntax I'm telling. Syntax. How to write. So if your condition here, whatever you are checking for, and then your statement. Then else. And then your statement. This is a syntax for the conditionals. For example, let's say you wanted to check if any person is eligible for vote or not, if he or she can vote or not as per their age. So what I can do, I can check if, let's say the criteria is if a person is greater than or greater, if the person's age is greater than 18, he or she can vote. And if the person is like smaller or if the age is lesser than 18, then he cannot or he or she cannot vote. That is a criteria you wanted to check. So now here I will put if age is greater than or equal to 18. Okay. And semicolon here. Then you can print here. This is my statement. I wanted to print. You can vote. Okay. Else, we can print here. You cannot vote. Now, let's say my age is 15 here. So here the age is 15 and here we are checking. If the age, which is 15, here we are putting this statement. If 15 is greater than equal to 18 or not. Because here we are replacing 15. So now 15 is smaller than 18. So this statement will not execute. So what this means, first we are checking if, and this is my condition here. This is known as condition. Here I'm checking if the particular age is greater than or equal to 18, then only execute this statement. You can see this statement is inside if statement. If this condition is false, then don't execute this part, execute this part. Okay. So if this condition is false, so don't execute this part. Rather, execute the else part. Okay. So here we are checking for two conditions, yes or no. If a person is greater than 18 or not, right? So here I can mention. So here I'm checking for two conditions. If a person is eligible for vote or not, either she can or he or she cannot. That is like my one condition. I am checking if that person can vote or not. So that is why I'm using if else condition. So whenever you are checking for two condition, only two condition, then you use if else. And whenever you are checking for more than two condition, you use if else. Okay. So here I can write. So here we can make a note. Whenever we are checking for two conditions, which means yes or no, then we use if else. If we are checking for more than two conditions, in that case we use if else. Okay, now here we are checking just for two conditions. A person can vote or a person cannot vote as per this condition here. So if this condition is true, the person can vote, otherwise not. So now the age is 15, which means this condition is false because 15 is less than 18. So this line will be executed. So if I run this one, you will notice you cannot vote because I cannot because I'm less than 18. If I put here 46, let's say, now this person can vote because 46 is larger than 18. If I put here, you can see you can vote. If even I put 18 here, so again I can vote because I'm checking for age greater than and 18, which is greater than and equal to 18, which means 18 is also included here. So if I run this one, you will notice you can vote because 18 is also included. If you want to exclude 18, you can just remove equal from here. Now we are just checking for larger than 18, not 18. If I put equal here, which is 18 is included here. Okay. Yes. So if I run this one, you can see you can vote. So this is a criteria. So you have to create your own criteria, your given condition, and then you create if else statement. Okay. You can also remove this else from here, which means it is not compulsory to put else here. Okay. For example, I am of 27, let's say. So if I run this one, you will notice I can vote. But what if I am, let's say, 12 years old? I cannot. So if you run this one, you will notice no output here, no output. Because we are not seeing for nothing here. Like we are just checking for if a person is greater than or equal to 18. We are not checking what if the person is less than 18. We are not printing anything. So that is why it is not compulsory to put else here, but we usually put else here. so that we can tell something to the user that even he or she can vote or not. So that is why I'm putting else here, that I wanted to tell a user that he cannot vote. Okay, you can also just remove this one, but it's your choice. It is like a good practice to put something in the else statement, which is you cannot vote. If I run this one, you can see you cannot vote. But if I remove this one,
There's
it
no
is not
output.
compulsory to put. You will see no output here because we are not checking for any condition which is less than 80. We are just checking for equal or larger than 80, not less than 80. Okay. One more thing here is in the if we use condition here, but in the else we never put any condition. Like we never put any condition here. Okay, we just put print you cannot, let's say. For example, here we cannot put like this one. Age is less than 80. This is wrong here. Because in the else condition, we never put anything. It is wrong. So
Mm.
remember, in the else condition, we cannot put anything. Why? Because just think of it, it is very logical. We are checking for yes or no. If one condition is false, another is always true, right? If one condition is true, another is always false. So that is why we cannot put a condition in the else. If one
Mm.
condition is true, automatically another is always false. Same as vice versa. If one condition is false, another is automatically true. That is why we are not putting else here. If a person can vote, it is automatically the opposite is he cannot vote, right? So that is why in the else we are not putting any condition. Just else, and whatever you wanted to print, you can print here. Is it clear?
Yes, very clear, teacher. Thank you.
Now what we can do in the conditionals, we mainly use comparison operators. We mainly use, that is comparison operators. What are comparison operators? We have this one greater than, we have this less than, greater than equal to, less than equal to, equal, and not equal. So we mainly use comparison operators while using if else statement. Okay. Now let's take another example. Let's say we wanted to print, we wanted to check if a number is even or odd. Okay. So check if the number is even or odd. So can you tell me what is even and what is odd numbers?
Yeah, for even like a 2, 4, 6, 8,
Exactly.
10. Yeah.
So the even number which is divisible by 2 and
Mm-hmm.
odd numbers which is not divisible by 2. So here we're just checking for two condition, even or odd. Okay, just two condition. So what we can do, we can use here if or else. So how we check? So in this program, I wanted to take input from the user. User can put any number and I will check if that number is even or odd. So what we will do, we will take input from the user. So how we can take input? We can use now equal int input. And here I can check, put here, please enter the number you wanted to check. Okay, that is my input here. Now I will use a condition here if number, which is whatever the number user will put, will submit inside this number variable. If number is divisible by 2 is equal to 0, then we can print number is even. Else, number is odd. Because if the number is not even, the number is obviously odd. So if the number is not even, it is automatically odd. That is like yes or no. If answer is yes, the another answer is no. If the answer is no, the another answer is always yes. Same as with the even and odd. That is why here we are using if or else only. Now this condition says, this is my condition here, which is number. Let's say here I am a user and I am putting number here. Let's say number is 4 here. I'm putting number 4. Now number 4 is an even number. So here I'm checking this condition. If number, what is number here? 4 is modulus. This is modulus sign. What is modulus? Whenever we are divisible by, like whenever we are dividing any number with the help of modulus, it will return remainder part, right? So like now think of, let's see, we are dividing any number. Okay, let's say this is 4 here and this is 2 here. We are dividing 2. So 2 into 2, 4 here, right? So we have 0 here, right? 0. This is remainder here. This is known as remainder, right? So here we are checking with the help of this modulus. Modulus will always return the remainder part, means this part. So here we are comparing if we are dividing any number by 2, if the modulus is equal to 0, which means the number is fully divisible by 2, right? If there's any remainder, let's say if we are dividing by 5, okay, let's say 5. So answer is 5. We can put here for 2 into 2, 4. So the remainder is 1 here. So if the number is not equal to 0, now this number is not equal to 0 because number is 1. 1 is not equal to 0. So there's a remainder here. There's something a remainder, which means it is not divisible by 2. So which means the number is odd. So this is my condition here. Okay, it is like a very simple logic. If there's a remainder, then obviously number is not divisible by 2. If there's a remainder 0, which means the number is completely divisible by 2. So this
Mm-hmm.
is a condition here. So if I run this program, let's run this one. I will clear my screen. We can move on, let's say desktop. I will run this file. File name is dictionary. Now it is asking for the number. Please enter a number. Let's say 4. You can see number is even. If I
Mm-hmm.
put here 45, number is odd because 45 is an odd number.
Yeah.
So this is why my condition. The only thing you have to put here is your condition and rest syntax is same only. The syntax will always remain the same. If, okay, if will always come in place of if, your condition here, your semicolon, your statement which you wanted to execute after this condition is true. If your condition is false, then you can put in the else statement. Is it clear, this part?
Yes, teacher, very clear.
Okay. Now what we can do, we can again check for. Now we can move to if else. Now what if I have multiple conditions? Okay, let's say we can just use for multiple condition. What if I have multiple conditions to check? Let's say I wanted to check if a number, let's say I wanted to put a score system. Okay, I wanted to put a grade system. In this grade system, I want a person to apply any number, let's say any score. On the basis of score, I will apply a grade here, like A grade, B grade, C grade, and so on. So let's say if the marks, or we can say the score, is greater than, okay, we can put if the score is greater than 100 to, let's say 85, we can put A plus or A.
Mm-hmm.
Okay, if the score of any student is, let's say, if 100, in the middle of 185, we can put A here. If the score is in the middle of 85 to, let's say, 65, we can put B. Okay. If the score is in the middle of 65 to 45, we can put C. And if the score is in the middle of 45 to 25, we can put D here. And if the score is in the middle of 25 to 0, we can put F here. So this is a great system I wanted to create. I want the student to put a number, to put a score as an input. And on the basis of the score, I will apply the grade. Okay. So here you can see in this setup problem, we have multiple conditions to check. We have around 5 conditions to check. So in that case, we will use if, else. How do we use? It is again very simple. We can use if. So what is the first condition to check? The first condition is this condition. If the score is in the middle of 100 to 85, which means if the score is less than 100 and more than 85, right? That is why it is in the middle of 185. So we can check if score. So what we can do, we can just take a score from the user. Let's say score equal int. We can put input here. Let's say enter the score. Now, if score is greater than or equal to 100, okay, equal to 100, and here I will use AND operator, and score is less than equal to 85, or let's say less than 85, then simply print grade in here. Okay, now here I'm checking. See, here I'm checking here. If score is greater than 100, which is greater or equal to 100, sorry, less than. Yeah, here you have to put less than or equal to 100 and greater than 85. Then, which is in the middle of 100 to 86. Because 85 is not included here. You can see we are just checking for the greater than, not greater than equal to. So 85 is not included here, but 100 is included here because of this equal sign. And here we are using AND operator. Okay. So basically we have to use OR operator here, I think. Yeah. We have to use OR operator, not AND. But if we use OR operator, so let's try with the AND first. So in the AND operator, we are checking for both condition, this condition also and this condition also. So if both conditions are true, then only we will have this grade A. Otherwise, we have this false here. Okay. Then second condition elif. Here we will use elif. The second condition says if the score is more than 85 and less than 65, which is we can use if the score is less than or equal to 85 and score is more than 65, which means this condition says print grade B. Right.
Mhm.
Then we can check for next condition, which is score is in the middle of 65 and 45. So we can check if score is less than or equal to 65, which is 64 and so on. And score is greater than this 45. Then we can print grade C. Another condition, which is 45 to this one. So simply we can copy this part and we can paste here. In place of C, we can put D. In place of 65, we can put 45. In place of 45, we can put 25. Right? So this is my last second condition. At last, we can put elif here. Here we can put score. If the score is less than equal to 25 and score is greater than or equal to 0. So here now I'm including 0. So here I can put UR. Here we have this graded F, like this one. Okay, now again it is not compulsory to put else or not. Okay, if you wanted to put, you can put else. But again here it is not compulsory. So this is my grade system I have created. Here you can see we have like 5 conditions to check. So this is if, elif, and so on. Even you can do like this one. We have this if here, you can also use multiple if like this one. You can use if here also, if here also, if here like this one. So you can also use multiple if, but we always use if, elif in the multiple condition. Okay.
Mhm.
Like if you wanted to use if all together, it is again fine. But we always use if, elif, else. Now again, it is not compulsory to put else here. So let's run this one. Okay. So let's clear the screen. Yeah. So let's run this program. Now let's say my score is 95. Let's say you can say grade A here. Let's say the score is 65. Grade C there because of this condition.
Mhm.
Okay, let's say the grade is 0. You can see grade F here. What if the
Mhm.
grade is in a negative number? -3. You can see we are not having any output here because we are not dealing with the negative numbers. So we can also deal with the negative number like this one.
Mhm.
Like we can put here again Alif. We can just put here if score is less than 0, which is negative, just print here invalid. And here we can put please put the valid score like this one. Okay, so we can use as many as if Alif statement here. So again, we can run this one. Let's say here we can use -5. You can see invalid. Please put the valid score. If I put here, let's say score is 46. You can see grade C because of this condition. In the middle of 46 to 65, we have grade C. So here we are having this multiple condition. The main thing you have to perform is to build your logic. That's it. Apart from logic, everything remains the same. You can use if, your condition, your semicolon, this one, then your statement here. If this condition is false, it will, if this condition is false, it will not execute this line. It will jump to the line number 206, elif. Then your condition here, if this condition is again false, it will move to next condition. Then this condition, if this condition is let's say true, so this will return this part and it will like complete your code. Okay, like if this condition is true, then it will execute this line of code and your code will be terminated. Like it will not
Mhm.
going to check the next condition. So if any of the condition is in the middle is true, it will not check the next condition. For example, let's say if my this condition is true in the first place, so and this condition, this statement will be printed. So my Python will not going to check for all these conditions because first condition is true. That's it. So that is why whenever you're putting the condition, make sure that are in the right sequence. Okay, that are in
Mhm.
the right sequence. It is not like the lesser number are coming first and the greater number are coming next. Okay,
Mhm.
so always put in the sequence. Larger number, then smaller number, and so on, like this.
Mhm.
Is it clear? Somewhat?
Yes,
Any
clear.
question?
Yes. No questions, teacher. Very clear.
So let's check for again a simple condition. Let's check. Let me remove this part. Let's say we have this number here equal 10. So here I wanted to check if this number is, if the number is greater than 10 or equal to 10. Okay, or anything else. So what I can do here, I can just check if number is equal, is first greater than 10. So just print the number is greater than 10. Alif. Number is equal to 10. So we can simply print the number is equal to 10. At last, else. What is the else condition here? Number is less than 10. If the
Then
number is
10.
greater than 10, we have this condition. If the number is
Mhm.
equal, we have this condition. What else remaining? Less than, because whatever the number is, it would be less than 10. Because for the greater than, we have already checked. For the equal, we have already checked. What else
Mhm.
remaining? Less than. So that is why in the else condition, we are not putting any condition here because this is the last condition or last thing to happen. So if I run this one, you will notice. Let me remove this part first. You can say number is equal to 10 because number is actually equal to 10. If I put 100 here, so this is number is greater than 100. If I put here, let's say 5, the number is less than 10.
Mhm.
So this is again a simple if else condition. It is not compulsory to use else always. It's your choice. If you wanted to put something, okay, apart from any other, apart from the true condition, you can put in the else condition. Like if the condition is true, the if statement will be executed. If the condition is false, the else statement will be executed.
Mhm.
Now we're checking for the number if the number is negative or positive. So how do we do this question? If the number is negative or positive?
Mm. Yeah.
So which
That,
statement we have to use? If else or if else?
um, yeah. So still, number equals to, or just enter a number, right, teacher? So
Okay, you are saying to enter any number. Let's say number is
yeah,
5. Yeah.
5. Yeah. Then if the same thing, if number equals, what do you mean? Yeah, equals to positive, right?
What is positive?
Yeah, that one's positive now. So we can say, yeah, that's hard. I don't know, teacher.
See, simple. If the number is greater than 0, it is positive. Less than 0, negative, right? So we can simply put if the number is greater than 0, greater than equal to 0, it is positive.
There you go.
So we can
Thank you,
put
teacher.
here positive. Else, it is negative because we are checking for just two condition. Else, print negative.
Negative.
Right. So number is 5, which is positive.
Mhm.
If we put, let's say, -5, number is negative here.
Yeah.
Okay, so the only thing we have to perform is to build our logic. Rest is same only. You can see
Hmm.
everything is same. Just the condition is keep on changing. It depends on your statement, your problem, what kind of problem you are solving.
Hmm.
Okay, and make sure of this indentation. This is known as indentation. This is space. It is known as indentation. Indentations are very important here. For example, if I remove the indentation part from here, it will throw the error. See, there's a red line around the print. This means I'm saying that if number is greater than equal to 0 and this print. Now this print positive has equal, we can say priority to everyone. So this print positive is not inside if statement. So we have to put inside. So we have to put indentation here, which is a tab key or a space here. So this is known as this part. This space before print is known as indentation. Same as if you click on enter, this will automatically assign an indentation here. So indentation is like a space before your statement. And it is very important. Otherwise, the Python will throw that error. If I remove like here, you can see space. If I run this one, you can see indentation error, which is we have to put the space before the print here so that we can tell the Python that this print statement is inside my else. Now here we cannot say this print is inside else because they are on the same level. But if I put a space here, you can see this print is now inside the else here. We can clearly see that. Okay, so that is known as indentation. Indentations are way more important for the conditionals. Okay, now next we can do this one. Let's say
Hmm.
we have a string here, or let's say list here. In the list, we have some elements here. Let's say we have element 1, 2, 3, 4, 5. Now here I wanted to check if 5 is in the list underscore 1 or not. So I can put a condition. If number 5, this one, I wanted to check for number 5. 5 in list underscore 1. Okay. So we have two condition. If 5 is present or 5 not present. Two condition, yes or no. So we can simply put print 5 is present. Else print 5 is not present. Right. This is my condition. So we have just two conditions, yes or no, 0, 1, or 5 is present or 5 is not present. So 5 is present. So answer will be this line, which is 5 is present. Okay. If I remove 5 from my list, now 5 is not present, which is as will be executed. This line. So make sure if your condition is false, this is my condition in my case. So this line will not execute it, never execute it. Your next if statement or elif statement will execute. Okay. This is known as if elif else or if else. Now, last topic we have nested if else, if elif else. What is nested? Nested means if statement inside if statement. For example, let's say we have value x here. Let's say 10 here. Okay, now I want to check if x is greater than 10 or not. Okay, just greater than 10 or not. If x is greater than 10, then check for another condition, which is if x is also greater than 20 or not. If it is print x is greater than 20, else print x is less than 20. Else here just print x is less than 10. So you can see here, we are checking for this condition. We can also put elif here. Okay, for equal sign. Or we can just put equal here. Just we can include 10 here. See, this is known as nested if else. This if else is inside first if statement. So if this is my condition, I'm checking if my number, my x is greater than or equal to 10. If this condition is true, then only check for this condition. You can see if and this else. These are inside this statement. So if this condition will be true, this line will be, these statement will be executed. Otherwise, this else will be executed. So if this condition is true, which is if the number is larger than 10 or equal to 10, we are again checking for one more condition inside this condition, which is if now the number is again larger than 20 or not, or we can say larger or equal to 20 or not. If it is, then print this part. If not, then print this particular part. Okay. And if this condition is false, then simply print this part. So what we can do, we can just check for 10 here. See, first we have this condition. X is less than 20. See, what we can do, we can print a statement here. Okay. Now we have another statement here. If I run this one, if x is larger than or equal to 10, first we have this statement, which is we are saying that, okay, x is greater than 10. After checking this condition, we are again checking for this condition inside the first condition. Now, if the x is greater than 10, now check for if x is greater than 20 or not. If it is, then print this one. If not, then print this one. Okay, so if I run this one, you will notice this statement will be printed and this statement will be printed. Because you can notice the number is 10. So 10 is not larger than 20. So first x is greater than 10. So now this condition is true because x is equal or greater than. If this condition is true, then we are going inside this statement and then this condition. Now this is checking for this particular condition. If x is larger than or equal to 20, no, x is not larger than or equal to 20. It is smaller than. So that is why you can see with this answer, x is less than 20, which is this condition. Because in the insider condition, this condition is false. But this condition is true, which is x is obviously less than 20. Because it is 10 here. It is less than 20. And this is how we use nested statement. If I put, let's say, 40 here. Now, what if this condition is true and this condition is true? So this statement will be executed and this statement will be executed. If I run this one, you will notice greater. X is greater than 10 and X is greater than 20 because X is 40 here. So this condition is true. If this condition is true, it is going inside this condition and then checking for this condition. Now, this condition is also true. So it is going inside, running this one. Okay, else will not return here, else will not print here because of this condition. Okay, and then if any of this condition is false, let's say if number is 5. So now this line of code will be executed because if this condition is false, then how can we move inside these condition because it is inside this condition. So S will be printed because X is less than 10. You can see like X is less than 10 in this point. Make sense?
Yes, teacher.
Okay. So this is how we can check for the nested if else. We occasionally use if else, it depends on the use case. Mainly we prefer to use if else statement. But if you want to check condition inside condition, then you use that if else statement. For example, let's say the condition is we have to check if the number is positive and even. This condition you wanted to check. Let's say number equal 5. So first we will check for the positive condition, right? So if number is greater than or equal to 0. Okay, which is number is positive. Then within this condition, I'm checking after this condition, I'm checking for if number is even. Okay, which is this condition. Then we can put print even. Else print odd. Else print negative. Okay, so this is my condition. So we have this number 5, which is first we're checking if the number is positive or not. If it is positive, then run this part because this part is inside the first condition. You can see lines here. This is space here. This is space telling us this part is inside the above statement, which means this statement is inside this statement. These 4 statements are inside the first statement, right? Because of this space, the space telling us if this condition is true, if the number is positive, then check for the number is even or not or odd. So we are checking again if the number is even or odd. So if it is even, then we have this even number. If it is odd, then print odd here. Else, if number is negative, then simply print negative here. So what we can do, we can just check for answer would be positive because number is positive here, but odd here. You can see positive but odd here. If I put -5, you can see just negative because last statement is running this particular statement. So if this condition is false, nothing inside this will print. It will directly jump to else statement. So it is like in the sequence. Okay, if one condition is true, we will jump inside that condition. If condition is false, we will jump to the next condition. Okay. Is it clear this much?
Yes, very clear, teacher. Thank you.
Okay. Now last question we can do, like last example we can try here. Let's say I wanted to check if a number is divisible of 3 and 7. Let's say if any number is divisible of 3 and 7. So let's see we have number 27. 21, sorry. Now 21 is divisible of 3 and 7 both. Because 3 into 7, 21, 7 into 3, 21. So now we are checking if any number is divisible of 7 and 3 both. In that case, what we will do? We will run if number is divisible, which is modulus 3 equals 0. If a number is completely divisible by 3 and we will use and here, number is divisible by 7. Then print here the number is divisible by both else we can put not.
Divisible.
Now, here we are checking for this condition. And here is because we are putting and here. Now the question says, a number, like whatever the user is putting any number, that should be divisible by both 3 and 7, both at the same time. That is why we are putting and here. And means this condition and this condition both needs to be true. Otherwise, like let's say if the number is 15. 15 is only divisible by 3. 3 5s are 15, right? But not divisible by 7. So this condition is false because and checks for both conditions. If both conditions are true, then only answer will be true. Then only this line will be executed. If one condition is true, let's say this one and this condition is false, this line will never execute. So this line will execute. Okay, if I run this one, you will notice not here. Not. Because 15 is only divisible by 3, not 7. If I put 21 here, 21 is a number which is both divisible by 3 and 7. So this line will be executed. Okay. Okay, so the number is divisible by 7 and both, sorry, by both 3 and 7. So this is how we are checking for any number. Now here we can put an input here so that we can take input from the user. Like here we can put int. Input, we can put here enter the number. And here we can run. Let's say number is 21. So number is divisible by both 3 and 7. Let's say number is 15. So not. Okay. You can put another condition if a number is simply divisible by 3 or simply divisible by 7. So in that case, you can just put here or. In this or, any of the number is divisible by 3 or 7, which means if the number is divisible by 3 or 7, say if number is 15, so 15 is a divisible of 3. So answer will be this line. Because we are using or. In the or, we are checking for one condition. If one condition is true, the answer will be true here. If answer is true, if the condition is true, this line code will be executed. Okay, so if I run this again, you will notice. You can see the number is divisible by both. Like we can remove both from here by 7 or 3. We can put 7 or 3 here. And if I run this again, let's say number is 18. So number is divisible by 7 or 3. So this 18 is divisible by 3. You can also check individually, like if the number is only divisible by 3, and then you can check for another condition only for the 7. Or you can combine both to check it. Okay, so this depends on your use case. But here we are just checking for one line only. In the one line, mainly we prefer to just make the just to make the code shorter. Okay, shorter in length, which means we wanted to end up the program in a very, very short line of code. Okay, the more line of code you will have, the more it will take to execute. That is known as space complexity. In the space complexity, we are checking for the space, how much space your code is acquiring. If your code is acquiring lots of space, your code is useless. No company will hire you or like use your code because of that space. If you're even decreasing one line also, that is very sufficient. Okay, so that is why we always prefer to just make the code shorter and shorter in length. That is very
Mhm.
important. That is known as space complexity. Second, we have
Mhm.
time complexity, which is we want the code to execute faster in the faster runtime. That is known as time complexity. It is like a part of data structures and algorithms. Okay, like just I'm telling you, whenever you're writing any code, make sure to write a code efficiently. Okay, because anyone can write a code. Main thing is how you're coding, how you're writing a code, whatever is
Mhm.
your, like, what is your space and time complexity, how much time your code is taking to execute, how much space your code is taking. That depends. That is really depends on the company. That is why
Mhm.
they they hire. That is like the main reason they hire, for checking if a person can decrease the space or not, or increase the time runtime or not. Okay. But we always have a trade-off between the space and time. If you are increasing the space, then time will be decreased. But whenever you are increasing the time, the space will be uh increase. Okay. So there's a like a trade-off. Okay. That is like just an introduction of the data structures. They are like very important, but they are mainly for the software engineers. Okay. If you are creating your own program, like for your own company,
Mhm.
for your own like task for performing some automation and so on, for anything, then
Mhm.
it is not compulsory to study data structures and algorithm. You can just go for the programming, but make sure whenever you are writing, try to minimize the length of your code. That is the main thing. If your
Mhm.
code length is minimized or like less, maybe the code will take some like less time to execute. But again, it is not always true, because there's always like a exchange between the time and space. Is it clear this much? Any questions?
No question, teacher. Very interesting now. I like these conditions and sample you know programs now.
Okay. So let's continue tomorrow. Tomorrow we will continue with the for loop and while loop. They are like more interesting than conditionals. And tomorrow only we will solve some questions on the if else statement and loops, so that you can
Yes.
practice also. And I will share some questions for assignment, and we will
Yes.
solve some questions in the class as well. Okay.
Yes. Thank you. Thank you. Thank you, teacher.
And in the meantime, please just revise these concepts. I will share the video within 1 hour. Okay.
Yes.
And
Thank you
I will
again,
share this.
teacher. Yes. Thank you again, teacher. Have a good day.
Thank you so much. You too.
Okay. Bye.